So I'm at a client meeting recently, proudly talking about all the various clustering techniques we have in our platform. And the client goes, why do you need so many? Don't you have one sort of the best technique to use in all situations? Well, the answer is no. And the reason is that you do need different techniques for different data sets. Let me show you a couple of examples. Imagine your data set looks like that. You can see sort of like a 3 round-ish blobs, one round, a couple of more, a little more squished. So how do you cluster them? Well, k-means is probably the most popular clustering technique. Let's try that first. What do we get? Well, to say politely, not great. You can see that the boundary of the clusters really goes right through the blobs, which is not a good answer. But if you think deeper, not a surprise. K-means is really assuming that the blobs are approximately round. So when they're elongated like that, it does not do a good job. What do? GMM to the rescue. GMM stands for Gaussian Mixture Model. This technique is much better at dealing with clusters of slightly irregular shape, different size, squished, elongated. You can see here it works much, much better. It correctly determines that, yes, these are 3 clusters. One is round, second is a little squished, and the third one is very, very squished, but it really picks them up from the data set very nicely. So is GMM the answer to everything? Well, no, not so fast. What if your data set looks like this? 2 sort of like partially overlapping moons. Do you apply k-means, GMM? Well, either of those will give you something which looks pretty bad. Again, it cuts straight through those clusters. It assumes that the blobs are approximately round, maybe elongated, round, but still roundish, and which is not the case here. It does not work at all too well here. What is the answer? dbScan, which stands for density-based spatial clustering with noise. A much better technique for this data set, because that technique assumes that the dots, which are closely packed together, are part of the same cluster. Doesn't matter, round, squished, overlapping, does not matter. If they're closely packed together, they're part of a cluster, which in this case works much better. So what is the answer? Yes, you do need multiple clustering techniques in your platform. Otherwise, for a particular data set, you may not have the right answer and you're going to be left hanging.